morning, students.
Good morning, sir.
Yes, good morning. Good morning. Please acknowledge in case the screen is visible.
Not yet, sir.
Is it visible now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, great. So in the last class, we have discussed about the computer systems, the basics of computer systems. Like we have discussed about the control unit, the arithmetic logic unit, the input devices, and the output devices. So in today's class, what we'll do is we'll be discussing about the memory portion or the memory unit of the computer system, like the primary memory and the secondary storage devices. Like what are the working principle of those devices? What are the different types of devices that are available in case of memories? And why do we need two different types of memories, where else we can have a single category of memory that is just a unit of memory, and we can use that memory instead of having that. Why do we have two separate units of memory? We'll be trying to understand that into this session. Okay, so let's get started with the CPU portion first. Okay, so yes, CPU, if we talk about CPU, is the central processing unit, or the processor itself is the unit whose task is to process all those input that are being supplied by the user. Okay, but while processing, there is a lot of thing that goes in the back end. Okay, the coordination of memories and the coordination of arithmetic logic needs to work together. So if the units or if the components they don't coordinate, we know that ultimately we won't be able to get the output. Okay, but let us try to understand what are the different components that we have inside the CPU. Okay, so basically inside the CPU we have the arithmetic logic unit, we know about that. Okay, we have a separate kind of memory, that is the registers memory. Okay, that is the registers memory, which is specifically meant for the specifically meant, or which is specifically integrated with the CPU. Okay, and the purpose of registers is something different in comparison with all the other memories. Okay, like we can have RAM, we can have ROM, but yes, on top of that, there is a separate category of memory, that is the registers memory, and that memory is basically integrated with the CPU. Remember, registers are always integrated with CPU. Apart from arithmetic logic unit, control unit, we have a separate memory, that are the registers. So what are exactly registers? If we try to understand that, we can see that registers are the unit of data holding places. Okay, like if you need to process a data, and while processing, if you need to hold something temporarily, in that case you will be holding the data in the register memory. So the workflow is as follows. For example, you have a data, and that data needs to be processed. Okay, the data needs to be processed as soon as the user, let's say this is the user, as soon as the user enters the data goes to the RAM. First of all, it will enter the RAM, random access memory. From RAM, it will enter the cache memory of the processor. Okay, from cache memory, it will come to the registers memory. Okay, from here, all the arithmetic logical operations and all will be performed. Like, for example, if you're performing 2 plus 2, okay, so the user enters 2 from the keyboard, it will directly go to the RAM. From there, it will come to the cache memory of the processor. From there, it will come to the registers memory. Okay, so while processing, this is the cycle which goes right. From this again, this will be sent back to the output device, so that the output can be displayed, or the output can be shown to the user. Okay, so yes, we are talking about the registers. The CPU uses registers to hold temporary data while processing, as I said. Yeah. Uh, Apart from that, if we say that registers can be classified into multiple types. Okay, registers can be classified into multiple types, and these are the following types on the basis of which you can classify registers. The first one is the data register. Okay, followed by the address register, accumulator, instruction register, program counter, temporary register, input register, and the output register. So each and every register have a specific task within them. Like the data register, the task or the purpose of data register is to hold memory operand. Okay, now if you talk about address register, the purpose of address register is to hold the address of the memory. Like if you talk about the accumulator is basically the processor register. Okay, and if you talk about the instruction register, the task of instruction register is to hold the instruction code. Now if you talk about the program counter, it basically holds the address of the instruction. So for each and every instruction, that instructions needs to be stored in some place, on some sort of memory location. Okay, so that address will be held by the program counter. So if we talk about temporary register, so temporary register will hold the temporary data. For example, while processing, you need to perform, let's say, 2 plus 2 first, and then multiply it with 3, like in the last class whatever I said. Okay. So first the 2 plus 2 is being done, so that output of 2 plus 2 needs to be stored somewhere, right? Okay, so that is basically the temporary data. So that temporary data will be stored in the temporary register. An input register will store the input. Okay, output register will store the output. Okay, so these are the different types of registers, from data register to the output registers, and all this are basically all this basically coordinate together to process a particular data so that you can get a flawless output. Okay, so yes, as I said, cpu doesn't cpu does cpu not only holds the following components like the arithmetic logic unit, control unit, and the primary memory. Apart from that, you also have the registers within them. Okay, and yes, the registers have some sort of serious stuffs to do, like as I said, as I've shown in this document. Okay, so in case if you have any queries from registers, in case you want to ask anything from the registers, you can ask, else I will be moving ahead. Students, in case you want to ask any query, you can ask from the register portion, and if the register portion is clear, please type Y in the chat box. Like, what is the task of register? To hold the temporary data while processing. What are the different types of registers available? And apart from that, what are the significance of each and every classification of registers? Okay, so this is what we have discussed as of now. And what is the flow of an input while processing, like from the input devices, how it flows to the processor directly. So if all the concepts are clear, please type Y in the chat box so that we can move ahead.
So the task portion.
Okay, which portion?
So the
This
task
portion.
of register. Yes, sir.
Okay, this portion you need me to explain once again, right? The function
Yes.
of each and every registers. Okay, so see, registers can be classified into the following types: data, address, accumulator, instructor, program, temporary, input, and output. Okay, data will hold the memory operand. Okay, memory operands are those on which you will be performing some sort of operation. Okay, let's say 2 plus 2, here 2 is the operand and plus is the operator. Okay, address register, if we talk about the address register, will hold the address of the memory for the memory. Okay, like if you talk about if you talk about data, so data will be basically stored in some sort of memory location. Okay, so it will look something like this. Please try to understand. Okay, so if you talk about data, it will look something like this. Let us imagine this is the RAM. This is the RAM you have, and yes, and here you want to store some sort of data. Let's say the numerical value 2 you want to store in the RAM. Okay, for this, definitely there will be a random address that will get generated. Let's say 0x101x. Whenever you supply the input, that will be stored in the register, right? Okay, so that will be stored in the yes, that will be stored in the register. But before storing the input or before storing the data in the register, what exactly happens is that the moment you supply the input, it will be first stored in the RAM. Okay, it will be first stored in the RAM, and for storing it in the RAM, a corresponding memory address will be generated for that particular value. Suppose you're storing the value 2. Suppose you're storing the value 2 in the RAM. The moment you enter the input will be stored along with the corresponding memory location. Okay, so this memory location is basically the memory address. Okay, and this memory address will be held by the register, like in which memory location that particular value is stored, so that that value can be fetched by the processor. Like if you don't know the address of a particular value, will it be possible for you to fetch that particular value? No, it won't be possible in that case. So definitely the address needs to be stored. Like if you know the address, then only you will be able to fetch the value. Okay, so this is the task of address register. So if you talk about accumulators, accumulators are the processor registers which will accumulate the values. Okay, now if you talk about instruction register, it will store the instructions, like what task needs to be done. Okay, so what is the task that you need to perform, what is the instruction that you have given to the system, like let's say addition or subtraction, whatever it is. Okay, Program counter holds the address of the instruction. Now the instruction that you have supplied to the register needs to be stored somewhere, and that will be done by the program counter. Temporary register will store the temporary data while processing. Input register will store the input value. Output register will store the output value. Okay, so these are the different types of register. I hope the concept of register is clear as of now. Okay, so yes, so if we talk about CPU, so these were the primary components of a CPU, like starting from the arithmetic logic unit, whose task is to perform arithmetic logical operations. Like any arithmetic logical operations, you name it, it will be performed by the arithmetic logic unit. Control unit will basically maintain the flow of the data. Okay, and if you talk about registers, while processing, we know that that data needs to be stored somewhere, and that data will be stored in registers. Like there are difference between cache memory, registers, and the primary memory. Let us try to understand those differences so that we can proceed smoothly, right? For example, this is let's say this is Rishi Saikya. Okay, this is Rishi Saikya. This is Rishi Saikya, and this is his friend Arman Das. Let's say. Okay, this is Rishi Saikya and this is his friend Arman Das. Okay, now Rishi Saikya wants to visit Arman Das. Rishi Saikya wants to visit Arman Das. Okay, fine. The distance between Rishi Saikya to Arman Das is 50 kilometer. It's 50 kilometer. Hypothetical situation. Okay, students, please try to understand that this is an hypothetical situation. Okay, so the distance between Rishi Saikya to Arman Das is 50 kilometer. Okay, now Rishi Saikya wants to go to, this is Rishi Saikya. Okay, let us try to understand by giving this Rishi Saikya and AD. This is Arman Das. Okay, now Rishi Saikya wants to visit Arman Das, but he's thinking to carry, thinking to carry ice cream for Arman Das. Okay, he's thinking to carry ice cream from Arman Das, and here in between, let's say in the distance of 10 kilometer, we have the distance of 10 kilometer, we have an outlet of ice cream. Let's say it is of Baskin Robbins. Okay, this is the outlet of ice cream. This is the Baskin Robbins outlet. Okay, but yes, as it is a hypothetical situation, let us imagine that Rishi Saikya is going to Arman Das' place by walking, by not taking any means of transport, or by not going through, he's not going through vehicle, he's using his legs to visit Arman Das. Okay, just merely by walking, he is going to Arman Das' place. So, in the distance of 10 kilometers, there is a shop of Baskin Robbins. He goes to the shop. He goes to the shop and says to give him an ice cream. Let's say family pack of ice cream for Arman Das. The shopkeeper gives the ice cream, and as soon as the ice cream is being received by Rishi Saikya, what he thinks that, let us go to Arman Das' place and give him a surprise visit. Okay, so yes. Now this distance that you have, which is of 40 kilometer, please try to understand it very carefully. This distance that we have, which is of 40 kilometer, and here we have Surya Devta, okay, who is showering his blessings. Okay, so will it be possible to provide the solid ice cream which he has bought from the shop, exactly that particular solid ice cream, to Arman Das? Hypothetically,
No, sir.
no external
No,
device,
sir.
no coolant, no cooler is available with Rishi Saikya. Please try to understand, he is just merely carrying the ice cream in his hands. Students, how many of you think, if it is not possible, please type N. If you think it is possible, type Y. I would like to know the answer of how it is possible. So if you think that it is not possible, please type N ASAP. Yes, exactly. That's not possible, right? Because here we can see that here we have here the temperature is also high. Okay, here the distance is also huge. That is 40 kilometers, not even 1 kilometer, 2 kilometers. That is literally 40 kilometers, which is only thing that Rishi will be able to give to Arman is the packet of the ice cream. Okay, and he will be able to say that I bought an ice cream for you, but yes, I bought a packet of ice cream for you, but unfortunately you just get the packet. Okay, I won't be able to give you the ice cream, right? So this was the case one. So let us try to understand a different case. This is the case two. Okay, so in case two, there is an outlet which is just 1 kilometer far away from Arman's place. Okay, which is just 1 kilometer far away from Arman's place. Okay, the distance is 1 kilometer. Please try to understand. It is just 1 kilometer far away from Arman's place. Okay, now Rishi, what he does, instead of buying the ice cream from this outlet, he goes to this outlet. He goes to this outlet and purchases the ice cream from this place. Okay, from this place he purchases the ice cream. Okay, so will he be able to give the ice cream in a solid form?
Yes, sir.
Yes, sir.
Okay, so
Yes,
Yes.
sir.
which case you will prefer, to purchase the ice cream from this place or this place,
The
So
second
from
option.
one thing. So second option.
right? Second option, exactly. So you will be going to the second option, right? The similar thing happens with CPU as well. Okay, instead of going to the RAM for each and every small instructions, for each and every small data, processor, what it does, in order to make the process faster, keeps a small amount of memory within itself. Okay, and that memory is basically the cache memory or the registers memory. Okay, keeps a small amount of portion of memory within the processor itself. So instead of going to the RAM, what it can do, it can come to the processor itself. While processing from the ALU, it can come directly to the memory of the processor to get the input, so that the processing can happen faster as well as smoothly. So what if the processor needs to go to this portion RAM and come back to the processor once again? In that case, the processing will get delayed. So in order to overcome that, we have a memory within the processor itself that is strongly integrated with the processor. Okay, so the same as you can see in this scenario, instead of buying the ice cream from this outlet, so it is preferable, it is preferred to buy the ice cream from this outlet because it is nearer to this, so that we can get the ice cream in a solid form. Okay, here the ice here we are here the example was related to the quality of the ice cream. At the same time, here the thing is related to the quality of the processing, right? If we say the processor is faster, that means the quality of the processor is good, right? Similarly, in order to make the transaction faster, we need to have a memory which needs to be strongly integrated with the processor. So how many of you have purchased laptop in the past, let's say 1 to 2 years, or let's say in the past 5 years? Purchase a laptop or PC, system, anything, or a computer. What were the specification that you went for? Most probably the processor, the RAM, the storage. How many of you went for the cache memory? Please type Y, double Y in the chat box. How many of you went for the cache memory? Please be honest, because the moment you say yes, there will be counter question for you. Okay, so let us go to go to the website of Flipkart and search for the cache memory so that we can understand it in a much more detailed manner. Okay, we'll be comparing two laptops, one which is of higher end, one which is of low range. Okay, which is the entry level laptop. Okay, let us take this example as of now. And for low range, let's say laptops, that's 30,000. Okay, let's see if we can get anything. Okay, we have this. Now obviously this laptop is going to perform better. Okay, but there are many perspective apart from the processor itself. Okay, the, there is the cache memory which will also help this laptop to perform in a much more faster way. Okay, so like if we compare the processor, that while seeing the specifications, you can see the size of cache memory is 12 MB. Okay, the size of cache memory is 12 MB, which is pretty much high. Okay, so generally we have cache memories of 2 MB, 3 MB in the budget laptops. So since this is a gaming laptop and which is a high-end laptop, you can see the cache memory is of 12 MB. But what if we compare this with this laptop? then the cache memory that you can see is just of 1 MB. Then definitely while processing, this laptop is going to lag. So what if you need to compare, if you're confused with these two products, let's say, okay, let's say this one with A9 processor, both of the processors are from AMD, this with A9 and this with A6, and there is a 1000 difference between this two laptops. Okay, not even 1000, there is, I think, yeah, few, yes, 10 rupees different within this two laptop. So which laptop to purchase, now you're confused with. Okay, whether you should go with this A6 one or the A9 one. So here comes the role of cache memory, so that it can help you out. Okay, apart from the clock speed, apart from the hard disk drive, apart from the ssds, apart from the battery backup, the next thing that you must, or you should definitely look for, is the cache memory. You can see here also you have the cache memory. So what is the next thing you should go for? You should go for this clock speed. So here the clock speed is 3.1 gigahertz. Now if we see the clock speed here, the maximum clock speed that it can boost up to is 3.6 gigahertz. So if you compare 3.7 to 3.6, then definitely this will perform better in comparison with this. Okay, because there is a 0.1 difference. Okay, in between these two between these two processes. Okay, so this is how you compare. So what if we compare this with this laptop? Let us try to understand if there is a difference between the cache memory. And this is a different processor by Intel, that is the Celeron processor. So if you go by the specification, you can see here the size of cache memory drastically changes, and it increases to 4 MB, directly to 4 MB. Okay, but the processing speed is low. So should you go for this laptop? Now the question is that, okay, the answer is obviously yes, because that is the turbo speed, that is the turbo boost of speed. But while processing, there needs to be some sort of data that needs to be stored in the cache memory. Okay, so if you go by this laptop, in this case the processing speed will definitely lag, because the memory size is very less while storing the data while processing. But if you compare this with that laptop, in this case this processor will definitely perform, or will definitely perform better in comparison with these two Lenovo laptops that we have seen, because the cache memory is huge. While processing, 2.8 gigahertz is sufficient to process most of the tasks that we will be doing as of now. Okay, so definitely we'll be going with this laptop because it has a 4 MB of cache memory. I hope the cache memory, or the concept of cache memory, is practically clear to all of you, like how to go for a laptop, or how to select a processor while buying or while purchasing the next PC.
Excuse me, sir.
Yes, Shashwat.
Sir, my laptop is showing 3 cache memory. How is that possible?
Please pardon.
Sir, my laptop is showing 3 cache memory, L1, L2, L3.
Yes, exactly. There are multiple levels of cache: L1, L2, L3 cache. Okay, the cache memory that you see over here is of L3 cache. Okay, each and every laptops have 3 level of cache. Nowadays, even you have 4 levels of cache: L1, L2, L3, and L4.
Sir,
So if we talk about ubiquitous memory, yes, please.
sir, so
Yes, sir.
if the cache memory is more but the speed is less, then it is okay. But if speed is more and cache memory is only 1 or 2 MB, then it is not good.
Please pardon.
Sir, you are saying that cache memory is
Yes,
important because that is where the processor will temporarily store and process the data. So
exactly,
after
exactly,
so
exactly.
the speed the speed of the processor like 2.4 gigahertz is not important
Okay.
compared to the cache memory.
I'm not able to get your question. Can you please say it once again? The speed of the processor is not important to.
Compared to cache memory.
The speed of the processor is not important when compared with cache memory. Yes, let me give an instance for this. Okay, so that you can understand it in a much more better way. Okay, so while practically processing, while practically performing any task, the first important task is to understand the processor in a very detailed manner. Okay, so if you go by each and every task, or if you run any task in the system, okay, if you run any task in the system, so if your system stays at 3.1 gigahertz each and every time, then there will be throttling issues. First of all, you will get the processor won't be efficient. Because let's say you're playing a movie, and at that moment of time, why do you need 3.1 gigahertz? So the processor needs or should have the capability to scale up and down as per as the user's choice. Yes, for desktop, this should not be the case. But definitely while running multiple processes, because definitely you're not going to run a single process while opening this tab, I might require, I should open this PDF viewer as well. I should have the capability to open this Excel sheet as well. During that time you will see certain stutters or certain frame drops, because in that time the processor will struggle to keep that particular data in the memory, okay, in the process memory. Okay, so this is first case. And the second case is that while purchasing a laptop, definitely go by this, because if the constant speed is 3.1 gigahertz, then definitely the cells number or the cells of the batteries of the laptop needs to be powerful. Okay, here you can see, if we go if we try to understand, or if you see the cells of the battery, then this is having a 6 cell battery. Okay, this is a good thing. So ultimately you're going to get a 4 hours backup. Okay, because yes, because each and every time the processor will be at its peak, like 3.1 gigahertz each and every time. Okay, so but if you run a small process, then also it is going to be a 3.1 gigahertz. Then in that case you will get a less battery backup. And if you get a less battery backup, then automatically the performance of the laptop will drastically drop, because the laptop will go into power saving mode. So the moment the laptop goes into power saving mode, there will be a sudden decrease in the clock speed as well. After a threshold value, the laptop clock speed or the process clock speed won't increase, because that will again turn in that will again push the laptop to a power saving mode. I hope I'm able to answer your query, Shashwat.
Yes, sir.
Okay, so this was all about the cache memory and the memories. Now let us try to understand the uh, primary memory and the secondary memory. So if you talk about the primary memory, then the primary memory can be divided into the following types. Okay, RAM and ROM. And if you talk about the secondary memory can once again be classified into the following types: hard disk drive, SSDs, compact disk, floppy disk, or magnetic tapes. But the thing is, like, why do we have two separate kind of memories? Like, while processing or while running any kind of input, the moment you run any program, the moment you execute any task, that task will directly go to the RAM. The reason is because RAM is strongly integrated with the motherboard. Okay, the reason why we have two different types of memory is because, first of all, RAMs are much more faster, strongly integrated with the motherboard. Second point. Third point, yes, the reason is because volatile. RAMs are volatile. That means the moment you shut down the system, you won't have the data. Okay, so in case if you need to store the data, that means if you need to store anything permanently, you need to store it in the secondary storage device. Okay, now the reason we have two different storage devices, because once again, as I said, RAM doesn't store data permanently. Okay, because the working mechanism is such that you throw the input to the RAM, it will send directly to the processor. It is not designed to store the data permanently. It is not designed to store the data permanently. At the same time, it is much time costlier. It is much time costlier than the hard disk drives that we have. Okay, since they are they're made up of much higher qualities. Okay, their materials that are used are of much higher quality. Their technology that are used for building the RAM is of higher quality. At the same time, the transaction speed of a RAM is faster when we compare it with the secondary storage devices. Because definitely, if we need someone to communicate with processor, we need someone which is much more times faster than the secondary storage device, and that is basically the RAM. Now the thing is, like, why do we call the RAM to be a random access memory? Why do we call the RAM to be a random access memory? So if you try to understand the concept of RAM, then it can be understood as follows. Okay, let's
But
say
can RAM
here I'm
also be
stating,
cached?
yes, let's say this is one memory location, and let's see if, yeah, these are the memory locations that we have. For 10 we have this memory location, for 20 we have this memory location, for 30 we have this memory location, for 40 we have this memory location, for 50, for 60, 70, 80, 90 we have this memory locations. Okay, now let us have a processor as of now. Let's see if we can directly copy a processor. Okay, yeah, this is a very good image of processor. Let's copy this image and paste it over here. Great. We have this processor. Okay. Now, what if the processor needs to access the memory? So what if the processor needs to access the memory? Okay. Let's say I want processor, please access the value 10. Processor will go to this. Okay. Processor, please access 40. Processor will go to this. Okay. Just see the arrows. Just see the arrows. Okay. Just see the arrows. You will get the meaning. Processor, please access 12. Processor will directly go to this. It means what? It is able to randomly access the values. I had the values. I was asking the processor to access 10. It was able to do it. I was asking the processor to access 20. It was able to do it. That's why we call this storage device to be as random access memory, because randomly it can access the values. If the concept is clear, please type RAM in the chat box. RAM. I hope as of now you have a better idea like why we call that to be as RAM, random access memory, because it has got the capability to randomly access the data from the RAM as per as the choice. So this was all about RAM. Like as I said, there are two different classifications: static RAM and dynamic RAM. Okay, now let us try to understand RAM in a much more detailed manner. Okay, RAM is basically the volatile memory, but the moment you turn off the computer, it won't be able to hold the data. Okay, now let us try to understand the different types of RAM that we have. That is the static RAM and the dynamic RAM. So if you talk about static RAM, then the static RAM can be explained as follows. Static RAM is that RAM which uses transistors to store a single bit of data. But if you talk about dynamic RAM uses separate capacitors to store each and every bit of data. Okay, static RAM does not need any periodical refreshment to maintain the data. Dynamic RAM needs periodical refreshment to maintain the data. Okay, so how many of you know about transistors and capacitors? In case if you have heard the term transistors for the first time, let me show you what exactly transistors look like. This is transistors. Okay, so if you try to understand, then you can see that static RAM uses these devices to store the data. Okay, but if you talk about capacitors, so what exactly capacitors look like? This is what exactly capacitors look like. So dynamic RAM uses this devices or this electronic components to store the data. Okay, so static RAM doesn't need or do not need periodical refreshment to maintain the data. Right, each and every time static RAM need not to get refreshed, so that so that it can store the up-to-date data. But if we talk about dynamic RAM, in case of dynamic RAM, the periodical refreshment is required. Okay, static RAM structure is complex than dynamic RAM, and dynamic RAM structure is simple than static RAM. Static RAMs are expensive, dynamic RAMs are less expensive. Static RAMs are faster, dynamic RAM are slower. The best example of static RAM can be the cache memory, and the best example of the dynamic RAM is the main memory that we have. So is the concept of static RAM and dynamic RAM is clear? Yes, please.
Sir, so D and DDR is dynamic. One D is
No.
dynamic.
DDR or those Ds in the RAM stands for double data rate. So yes. So this was all about the primary memories RAM part. Okay. In the next class, what we'll do is we'll be discussing the ROM part.